So it's important to understand that we are not solving an equation, okay? And maybe you make yourself a note. Note. We are not solving an equation. And I think it's important to remember that as we work through this. We are not trying to figure out what values for x make this equation true. We are trying to figure out, is this statement true? Now, just for your own sake, you can know that I'm never going to give you one that won't be able to work. Like, you're always going to be able to verify. It's possible to verify it. Our goal is not to have you work all the way through it and then not be able to verify it. That doesn't make any sense. So let's go ahead and jump in and try a couple here. That's just not example 2. It's example 1. Mrs. Kopp forgot to count. All right, so let's say I gave you this. Tangent squared of x plus 1 times cosine squared of x minus 1. And I want to show that that is equal to negative tangent squared of x. So when I'm analyzing this, before I even start to jump in and start working, I need to decide which side I'm going to actually work on. Yeah, absolutely. This side is a lot more complicated than this. If I told you, figure out how to write negative tangent squared in this way, you'd have a hard time doing it. But here, on the left side, we've got some things that we could use. Take a look at your Pythagorean identities. And right off the bat, hopefully you see tangent squared of x minus 1 is going to be what? Secant squared. So we've got secant squared. Now, we need to be careful with cosine squared minus 1. Because that's not exactly what we see. Now, maybe you're able to figure out a way to sort of rewrite it using just a Pythagorean identity and get it down to one term right away. But here's my suggestion. Until we're more comfortable with that, and some of you might be, and that's fine, we can take this cosine squared and change it into something using our Pythagorean identity. So this guy right here, if I use my Pythagorean identity, is the same thing as saying 1 minus sine squared. So I just changed cosine squared into 1 minus sine squared. Now, doing that alone should give me something that I can simplify a little bit more, and we're going to stop after this step and sort of analyze what we have. I see that we've got, 1 minus 1 is 0. So what's left is just negative sine squared. Now you're going to notice that I rewrite that right side, the side I'm not changing, I rewrite it every single time. And there's a lot of reasons for that. First of all, that's just proper notation. Secondly, every time I write that, it forces me to think about, that's what I'm trying to get to. Am I getting closer to that goal? Am I getting further away from that goal? Okay? And then maybe I need to analyze what I'm doing and change my strategies. But I get to this point and I see, I've got this negative sine squared. I've got this negative tangent squared. I see the negative sign. That's a good thing, right? I know that at least this side's going to be negative and this side's going to be negative, so I'm heading in the right direction. I know that tangent squared, if I thought about that, is sine squared over cosine squared, right? Tangent is sine over cosine. Well, I've got the sine squared piece. Maybe I'd try to change this. So I'm going to go to my go-to strategy, which is changing and making everything look like sines and cosines. And how could I change secant squared into something that uses just sine or cosine? 1 over cosine. Yeah. So I'm going to make this 1 over cosine squared. And I'm multiplying that by negative sine squared. And you'll notice I did a couple of things when I rewrote that step. First, I got rid of the parentheses. Since I'm multiplying and there's not like multiple terms that I'm multiplying, I don't need to worry about distributing or anything like that, so I can get rid of the parentheses. Second thing is, I'm going to do it right now. You guys should know by now, if I see one fraction, I'm going to make everything a fraction. So I'm going to make that be negative sine squared over 1. Now, you should say to yourself, hey, I'm getting close. Don't jump the gun. Be very systematic. If you're unsure about whether you should show a step or not, show it. Okay? Like, err on the side of caution. Show everything. So I've got, what? If I multiply these two fractions together, I'll get 1 times negative sine squared in the numerator. So that's negative sine squared. Over cosine squared times 1, which is cosine squared. And hopefully by now you're like, yeah, Mrs. Kopp, we got it. But here's the thing. We have to actually show that the left side is negative tangent squared. Like, I can't just stop here and say, oh, we're done. I need to actually write negative tangent squared because of the quotient identity, which says that sine squared over cosine squared will be tangent squared. So the negative would be negative. Negative tangent squared equals negative tangent squared. That's my goal. I have to show that that statement is true. Now, a lot of mathematicians, this is essentially a proof. Okay? When we're done with a proof, we do one of two things in mathematics a lot of times. A lot of times you're going to see this little box, like a little rectangle that is sort of filled in, that just indicates, it's like a period at the end of a sentence. Just indicates that this is the end of the proof. Okay, so you can use that, or I'll show you what else you could use on the next problem. So that's the first example. We took what was on the left, we rewrote what was on the left until we got what was on the right. Now let's try the one. So let's say I have this. Secant times cosecant equals tangent of x plus cotangent of x. So now you might look at this and say, well, I don't really know which side is more complicated than the other. So let's talk about how we could decide in this situation. Because I see 2 trig functions on the left, 2 trig functions on the right. The ones on the left are being multiplied together, right? So we would say that's one term because they're multiplied together. But the ones on the right, that's 2 terms. So it might be easier for us to try to add 2 terms together versus trying to make one term into 2 terms. You know, it would be the same as if I said, you know, take 30 and show that it's, I don't know, two numbers added together, but I'm not going to tell you what those 2 numbers are, right? So it's a little bit harder to do that. So we're going to take the right side and work on that side this time. So I'm not going to do anything to the left. I'm going to leave the left, and I'm going to rewrite it each time. What can I do to the right side, though? So we need to think about some of our strategies. We don't have any squared trig functions. I can't factor. I can't use Pythagorean identities. We could change them into fractions. So we have some options there, right? I could change tangent into 1 over cotangent. I could change cotangent into 1 over tangent. But my go-to strategy is to use sines and cosines whenever possible. So how could I change tangent of x into something that uses sine and cosine? Sine over cosine, right? Absolutely. So sine over cosine. Now I'm going to do the same thing with cotangent. So cotangent would be cosine over sine. Good. All right. So now I've got on the right side 2 fractions being added together. Well, that's good because we know how to handle that. Like, I can add those together now. I have a process for adding fractions together versus what I had in the original step, which I don't know how to add those together. But now that I have fractions and I want to add them together, what do we have to have in order to add fractions together? Same denominator. So I'm going to multiply my first fraction by sine over sine. And I'm going to multiply my second fraction by cosine over cosine, right? And then that's going to give me the same thing in both denominators. I've got sine times cosine in both denominators, and that's my goal. Because then I can probably, hopefully, do something with that. Now I'm going to be super intentional and really slow through this process. It is possible you can work through it a little bit quicker, but I just don't want to, I don't want to skip anything right now when we're doing these for the first time through. So that first fraction is going to have a denominator of cosine of x times sine of x. The numerator is sine times sine, which is what? Sine squared. Good. So we have sine squared. All right. The second fraction has the same denominator. Now I could write it as sine times cosine or cosine times sine. It doesn't matter. That means the same thing. So I'll write it like I have the other fraction written. And then I've got cosine times cosine, which is cosine squared. Awesome. So I've got each fraction simplified. Now let's take that one further step. And like I said, I'm being super intentional about what I write here for a lot of reasons. I don't want to skip any steps. I want this to be helpful if you look back at it later. All of those things apply here. So now that I have my two fractions with the same denominator, I can add them together. I'm going to add them together and they will have whatever their common denominator is. So cosine times sine. Bless you. In the numerator, I'm going to add together the sine squared plus the cosine squared. So I'm just going to have sine squared plus cosine squared. Now as you're writing that, as you're hearing me say that, I hope that it's triggering some kind of recollection that, hey, that's something that sounds really familiar. Maybe I need to look at my reference sheet. Yeah. So secant of x times cosecant of x, I'm not going to change the left side. But in the numerator of the right side, this guy right here, that is your Pythagorean identity. That's the basic that's the one we started with. Sine squared plus cosine squared is just 1. So we have 1 over cosine of x times sine of x. Now here's where it can be a little tricky to figure out, like, how do I change this side to make it look more like what I see on the left? And I'm hoping that what you're noticing is that secant and cosecant are reciprocals of cosine and sine. That's a good sign, because that's essentially what I have written. But if you're having trouble seeing that step, what I would recommend is maybe we do this. I'm going to do one additional step before we get to the last line in this proof. I'm going to split these fractions up because I have something that when I multiplied together, I should get what's up top there. So in other words, I had maybe 1 over cosine times 1 over sine. That would give me the 1 over cosine times sine, right, if I multiply those together. And then you can make a pretty simple substitution from that point. It makes it a little bit easier to see the direct relationship between the left and the right side. So 1 over cosine is what? Secant. 1 over sine is what? Cosecant. And then you've got both sides that are exactly the same. The goal is to get to be able to write the left and the right side are identical. If you don't like the little rectangle, you can put a little check mark there and say, yep, we're done. We proved that. We're finished. I don't need to do anything more. Use one of them. It's helpful for me to know like where a proof or where one of your problems ends, especially if you're doing everything on a piece of paper. All right. Questions so far? Okay, I want to do one more, and then I'm going to have you guys try some. Last one. Okay, this time I'm going to make it a little more interesting. We're going to throw some fractions into the mix right from the start. So cotangent squared over 1 plus cosecant. And I want to show that that is the same as 1 minus sine of x over sine of x. So there are some questions we need to ask ourselves here. When you're trying to figure out which side is more complicated, it's not immediately obvious. Right? So the left side is a fraction. The right side is a fraction. They both at least have two terms in one part of their fraction and one term in the other part. The thing that sort of draws me to one side versus the other is that, the right side has all the same trig function in it. It's all sines on the right. But on the left side, I've got a mixture of trig functions, cotangents and cosecants. So I would probably pick the left side because it's got that mix of trig functions. So now I've got to figure out what's my strategy. Well, okay. Cotangent squared. We have lots of options. We can, right off the bat, change everything into sines and cosines. We could try to use our Pythagorean identities and see where that leads us. There's other things that you could do here as well. I'm going to, for this one, maybe start and maybe encourage us to start with looking at our Pythagorean identities. Because I might be able to find a way to write cotangent squared a little bit differently. So how could I write cotangent squared differently using our Pythagorean identities? Cosecant squared minus 1. So I'm going to take this cotangent squared and rewrite it as cosecant squared minus 1. So this guy becomes cosecant squared minus 1. Now, I like to, stop along the way, even if it's just pausing for a moment, and make sure that I'm making progress towards what I'm trying to get, right? So I went from having cotangents and cosecants to now having all cosecants, which if I compare that to my other side, the other side is all sines. Now, that's kind of a good thing because what's the relationship between cosecants and sines? They're reciprocal, so that's giving me a little bit of hope that maybe we're heading in the right direction. Doesn't mean we're close, it just means we're going in the right direction. Okay, now, as far as what we do next, again, I think there's probably some strategies that you could use that might differ from what I'm going to do, but I'm going to stick with some things that are like tried and true strategies. So what I might do is I might recognize that guy is a difference of squares. And we did one like that yesterday where we had like sine squared minus 1. And we said that's a difference of squares. We can factor it. And so we did. I'm going to factor that difference of squares. Okay, so I'm going to factor it. And let's see what we would get. So something times itself has to give me cosecant squared. Well, it's got to be cosecant. Something times itself has to give me 1, so that's got to be 1. And then because I'm factoring a difference of squares, I know that one of them is going to be plus 1 and one of them is going to be minus 1. All right, looking at what we have. Anything jump out at you? There's a giant 1, isn't there? That cosecant of x plus 1 and 1 plus cosecant of x, those are the same factor. So I've got a giant 1 that I can get rid of. So this guy, we can say, is gone. And then let's see, what's left? So we're going to have, on the left side, cosecant of x minus 1. And we're trying to show that that will be 1 minus sine of x over sine of x. Now, we're still in good shape because we still have, cosecants and sines, and that's sort of what we're going for here. But on the left side, I have cosecants. On the right side, I need it to be sines. So that's a simple change that I can make. I can change my cosecants into sines pretty easily because what is cosecant in terms of sine? 1 over sine. So let me change that that cosecant to 1 over sine. Still have the minus 1. And I know writing that right side over and over and over again gets really tiring, but it's helpful because every time I write that, I'm forced to compare it to what I just wrote on the left side. And again, we're getting closer. Now, at least on the left side, I've got a fraction that has a denominator of sine. That's getting me closer to what I have on the right side. If you've heard it from me once, you've heard it from me probably 100 times. If I have one fraction that I'm adding or subtracting a number from, I'm going to make everything a fraction. So I'm going to turn that 1 into 1 over 1. Let me write that a little bit nicer here. It won't let me erase that. So let's make this 1 over 1. Because now I can add or subtract those two things from each other by getting what? If I want, yeah, common denominator, right? So I need to multiply my 1 over 1 to get my common denominator. So I'm going to multiply by sine of x over sine of x. Again, I'm going to be super intentional as I work through this process. As you do this on your own, maybe you don't need to show as many steps when you're when you're adding fractions together. But for right now, I'm going to show every step. Now, if I compare the left and the right sides, those are really close, aren't they? I just have to combine the left side into one fraction is all I need to do. So when I do that, the denominator is going to be sine. And the numerator is going to be 1 minus sine. And then lo and behold, that's what we were going for.
How would the denominator be sine? Isn't sine minus sine?
Remember?
Oh, yeah. No, I got it.
Yep. Because that's the same thing you were trying to do yesterday. Yeah. So your common denominator is sine. We got a numerator is 1 minus sine. That's perfect. That's exactly what we wanted. So if you want to use the little rectangle, the little check mark, it doesn't matter. You guys decide whichever one you like better. Just something that shows me you're done and you know you're done. So like I was saying before, your work, your answer is not this, right? That's not what I'm going for. That's not like, I'm done, I just show that. And that's why there's no text box on your GoFormatives to put an answer into, because your answer, your solution is all of this work that we just did for this problem. So this entire thing would be what I'd want to see in my solution box. So it takes a lot of practice and a lot of, trying and failing. And you're going to learn. Every time you try and fail, you're going to learn something about what to do next time. So don't get discouraged. In fact, I'm going to just say, when you go through the homework tonight, you're probably not going to be able to do all of them, and that's really okay. Because we'll talk about them tomorrow. We'll go through some of the questions you have tomorrow, and then you can work on some more. So the moral of the story is you have to practice.